Do you think you have it, or time to see it? Okay. So, in the question, I told you that I drew, you know what, I'll put on the graph first here. So you have 2 points on the graph. The first one is x, and we don't know where x is, of course, so we'll mark it there. And there's another one here called y. And the first thing I tell you is that the area to the left of x is this number, 0.1093. Yeah? I tell you that right there. So that means the value of x on the graph, its area, is 0.1093, but x is a negative, so 1 minus the opposite sign of x, which will be a positive, equals 0.1093, which means 1 minus 0.1093 equals that at the minus x. So 1 minus that, please, Iad. 0.8907. Yes, that's equal to that. So that means if I go to my table, I'm sorry, what did I write down? 0.8907. 0.8907 is 1.23. So that means minus x equals 1.23. So x equals minus 1.23, which is good. That gives me the x now. Yeah. Now let's get the y. So I tell you between x and y is 0.8252. So that means the y1 minus the x1 is 0.8257. Isn't that what I said? Wasn't it? 8257? 8252. 8252. Now the good thing is we know the x now, so I can say the y minus, and then this is 1 minus the value at 1.23. That's equal to 0.8252. But we work that out as 0.1093. So phi y equals 0.8252 plus 0.1093 if I just take this to the right. So I get then 0.8345? No, that's wrong. 9345? What do we have there yet? 0.8252 plus 1093. 0.99345. Okay, so now we need to look that up. 9345. And 9345 is right there, 1.51. So now I have the y then. Your solution's right? You got it right? Okay. It's okay? We can continue. So number 19, we're looking for 2 points on the graph, whereas the area between the 2 points in the negative and the positive in this case is 0.6827. all the questions are the same in 19, so one example is enough, then I'll let you try one. So here we want the area to the left of z minus the area to the left of minus z should equal 0.6827. So we're saying this area in red minus this area in blue should give us our green area in between that we want. But using our rule that we have, this is 1 minus, and then we flip the sign. That's 0.6827. So that would be 2 of these minus 1 equals 0.6827. So if I just do a bit of rearranging here, 1.6827 divided by 2. What's that, please? Yeah. 0.841435. So 1.4 then. So if we look up 8414, 8414, this is the closest I can get because the next one is too small. So that would be 1. So here z is 1. So in other words, we have the result that the area between minus 1 and 1 is what we need to make 68.27% then. So the answer is 1 here for this one. Okay, write that one down. So I don't think you tried that one, no? What? You should be. Please. Give me more cable. Thank you. It's part of it. You wrote it down already? You got that? Admiral? Yes. Yeah, I'm sure. You're too busy looking out the window. Now you got it?
Yeah.
Okay. So, if we have a look at the next one here. So we'll just finish by letting you try B, please. So just give B a go here. It's the same as A, except the only difference is 95% is the area. Is correct for this one. Could you actually just quickly do C as well? You see that it's a tiny bit bigger than B. but the result actually is important. Two. So if you remember at the very start when we were doing histograms, I said that the width is roughly 2 standard deviations when we were doing standard deviations. And remember, for these graphs the mean is 0 and the standard deviation is 1. So what you're saying is most of the time, over 95% of the time, you'll get a number between -2 and 2, but remember 1 is 1 standard deviation, so it's like you're saying 95% of the time you are between -2 standard deviations and +2 standard deviation. In other words, most of the time you're within 2 standard deviations of the centre. Yeah? Now, if you were to look at D, I believe the answer for D is 3. I think. Yeah. So, can you see that there's not much extra area when you go from 2 to 3? Most of the area is from -2 to 2. If you go from -3 to 3, how much more area do you get? You don't even get 5% more. You get like 4 and a bit percent. So often in probability and statistics, it's very common to look at how wide it is for 2 standard deviations, because most of the time that's the width that is interesting, because that's most of the time where you are within 2 standard deviations of the centre. This will become very important. The reason I put this at the end is because this idea is very important in the next lesson, but extremely important in the final lesson. Okay, and in fact, it's probably useful for the exam to actually have these memorized. So what I mean by that is, the second one you must memorize because it comes up in the exam most of the time. A question where it says, what is the sort of range left and right to get 95% of the data? You've worked it out as 1.96. Okay, most exams have that question in it. You don't have to have it memorized because you learned how to look it up in the table book, but it's a time saver if you have got it memorized, and the marking scheme won't punish you for just writing down the answer, because it's kind of expected that this is a memorized value, a bit like how you know pi is 3.14. It's like the statistics version of that. So this last question, quite important. Alright, we'll leave it there. So